Hello. Good afternoon, friends. I'm Satish here from Pagnan AI. So, this is the second video on the set data type. So, in the this is the video series where I will be discussing one video, one topic, and since that topic is very big one, so I'm trying to do two multiple videos on the set topic. In the first video, I have discussed about what is meant by set, some key characters of the set, and some basic operations on the set, operations like methods of set, like copy, add, remove, and all those things we discussed in detail in the video one. And this second video, I will be trying to discuss about some set of operations of sets actually. And if you don't remember what is the set and all those things, you can watch the first video and get refreshed with about the set, and then you start watching the second video. So as I discussed in the first video, saying that like set data type is based on the set theory or basic mathematics set concept. So since mathematics set theory, there are some operations, set operations are there. So we'll be discussing those kind of operations here. Like maybe you maybe heard about union of two sets, intersection of two sets, and all those things. We'll be discussing those kind of operations in this video in detail. So let us first start discussing what all the operations, basic set operations supported by the Python. Python supports these four basic operations. What are those? Union, intersection, difference, and symmetric difference. These are the four basic set operations supported by Python. So other than that, like there are a few more methods are there. So difference update, intersection update, symmetric difference update. We'll discuss that also. And there are some more Boolean operations are there and built-in functions are there. We will be discussing on those functions, those methods in subsequent videos. Now, because I don't want to discuss a lot of things in one single video. So we will be focusing on only the set basic operations, union, intersection, and difference. So let us start with one. So called union. Union of two sets. What is the union of two sets means? So let us consider two sets. Actually, there is set one and there is set two. So set one consists of 1, 2, 3, 4, 5, 6 elements. So it is a set of natural numbers from 1 to 6. And set two consists of 2, 4, 6, 8. What is that actually? It is a set of even numbers from 2 to 8. So these two sets. So when I say that like union of set one and set two, means like how it is actually set one union set two. So how should I do? So something that like this is one set and this is second set. This is set one and this is set two. And there will be some elements here, some elements which are common to set one and set two will be represented here. So which are the common here? The elements which are common to set one and set two are 2 is 1, 4 is 1. So these two are common to, and even 6. 6 is also common to both sets. Like so, the 2 is here also, 2 is here also, 4 is here also, 4 is here also, 6 is here also, 6 is here also, 6 is here also. So 2, 4, 6 will come here. And what is the remaining? So 1 is here, 3 is here, and so here only 8. So this is S union S2. So when you look S union S2, what could be the output? Output is, so first I should be considering this element. What is this element? This element is something which will be part of set one, but not common to set two. So what is those elements? 1 and 3. So next, what I will be doing is actually I am trying to convert these elements. What is those elements? So there are elements of set two, but that is not common to set one. So that is 8. Then I will be considering these elements. What is these elements? That is the common to both of these sets actually. That is 2, 4, and 6. So 2, 4, and 6. So it's like when I say union of set 1 and set 2, so this all elements will consider as a union of set 1 and set 2. So it will consist of 1, 2, 3, 4, 5 and 6 actually. Like I forgot here to add 5. So 5 will be here, correct? So 5 will be here, and this 5 will be here. So this is these many elements will be there. Like one. So these elements will be part of S1 union S2. Means like, what is that means actually? Like the elements which are common to S1 S2 will be considered only one. Rest all elements, but all elements of S1 plus S2 and only elements which are common to S1 S2 is considered only one. If it is there, it is not again added, because even though if it is there in the two cells, but only once it will be considered, because that doesn't consider duplicate elements. So that is the reason. So how should we do programmatically? So let us create a set A. This is set A I'm trying to create. So this is set A, and I'm trying to create another set, the set B. So I'm trying to create set A and set B. Then how should I do union? Using union method. What is that actually? A union. So it's A dot union in the bracket B. So it's like A union B, or B dot union in the bracket A. It's like A union B or B union E. So it is something like this actually. Whether I'm trying to do S1 union S2 or S2 union S1. So both will do the same thing. So both will give the same result. Whether we are doing S1 union S2 or S2 union S2, both are same. So whether I'm doing A union B or B union A, both are same. And another thing is actually I should be also doing union using a bitwise OR operator. This is bitwise OR operator. If you don't understand what is the bitwise OR operators and all different operators, you can watch the operator videos. There is one more video where one more video series I'm doing on video operators. You can look into all those operators supported by the Python. So this is the bitwise OR operator, bitwise OR operators. And if you don't understand what is the bitwise operator, you can watch those videos and understand what is the bitwise OR operator. And there is one more operator is called, that is normal OR operator. So here I will be using bitwise OR operators to do union of two sets. So if you see the result, so result whether I do A union B or B union A or using bitwise operator, the result is same. So both. And if you see here actually here the 4 and 5 is the common, so they are considered only one actually. 4 and 5 is considered only one. So this is how I'm trying to do union of two elements. And this is one simple example. So I wanted to check whether is there any element common or there. So is there any element common between two are there, two sets are there or not. So let us consider element set A with these elements and set B with these elements, and let me calculate length of set A and length of set B. LEN is the built-in operator to use to get a length of set. What is the length of set actually? How many elements are there in the set? So when I say length of A means like I will get actually 1, 2, 3, 4, 5. So means like length of set A is actually it will give value 5 because 5 elements are there in the set. So it is also called ordinality of a set. So length A will give how many elements are in the set A. Length of B will give how many elements are there in the set B, and I am assigning those to a variable A and variable B. So now what I'm trying to do? I'm trying to do union of A and B, and I'm trying to check the length of that union A and B. So union of A and B. So now that value I'm trying to show here. So why I'm trying to do that is actually I'm trying to see that like is any element common between set A and set B. How should I do first actually? So if there is a common, some elements are common between A and B. So something like this, if I do some diagram, something like this. No? So if there are some elements here, these elements will be considered only once actually, only once in the union. So means what happens actually? This element, and this element will consider only one. But independently, if you have taken this length and this length actually, and if you add it, means like this common element will be present here also, means like when you add length of A plus length of B, then this common element will be considered twice. But when you do union of A and B, the common element will be considered only once. So what happens actually? So when I say length of A and length of B, so length of B now means like the common, if I assume that like the two elements are common, so those two elements will be here considered here also, and when I say length of A union B. So if I say A union B, so now this 2 is only once considered. It's like, so when I do this length plus this length minus length of the union of this one, so I will be, this 2 will go off with this 2. So this 2 go off and only this 2 will be left out, because the rest remaining will be striked off. So that is what I am trying to do. What I am trying to do is actually, is there any common elements exist or not? So what is that means actually? So only once I am trying to consider the common elements here. So, but when I add these two elements, I am trying to add the length of common elements twice. So if there is any elements are there, common elements, and this value will be something like what I will be getting is actually will be that number. So for example, if there is no common elements are there, like for example, if you say 1, 2, 3 is one set, so set A, and if I try to do 4, 5, and 6, so this is set B. So if you say length of A, that will be 3. If you see length of B, that will be 3. Then if I do A plus B, then it will be 6. A plus B is equal to 6. So A plus B is 6. Now if I do A union B, if you do A union B, what if happens actually? A union B is actually, it will be 6. So this 3 number and this number 6. So if I do A minus this minus this A union this one, the result will be 0. So what it indicates actually, if result is 0 means like there is no common element between these two sets. If there is a common element, the result is greater than 0. So result is greater than 0. If there is no common element, then this equation, what is that equation? Length of A plus length of B minus length of A union B will be 0. So if these two sets A and B sets are doesn't have any common element, then this equation gives the result 0. If this equation gives any number greater than 0 means there is some common elements are there in these two sets. So this is how I am trying to check. If there is the problem statement comes actually, check actually is there any common elements are there. So this is the without using intersection kind of operation. So if without using those kind of operations, if you wanted to do or check the is there any common elements are there, then you should be doing something similar to this kind of equation. So I'm not trying to use intersection. But if you wanted to find out the common elements between two and set 1 and set 2, the straightforward approach is finding the intersection of these two sets. So what is the intersection of these two sets actually? Whenever if I'm trying to say that like intersection of two sets means that I am interested in to find out only the common elements between these two sets. So this is a straightforward method, set operation, so to find out the intersection of this. It's like what is that means actually? So if I give a set A and if you give a set B, and I'm asking you to find out what is the common element between these two sets, then I should be performing an intersection operation. So in mathematically, this is how it will be representing the intersection of the operation of the two sets. So assume that like, so same thing, like I say 1, 2, 3, and 4 is a part of the set 1, and 4, 5, 6 will be part of the set 2. Then intersection of something that like how it looks like. So this is set A, this is set B. So this common element will be here. This is 4 will be here. So 1, 2, and 3 will be here, and 5 and 6 will be there. And A intersection B will be, so only this common element. What is that common element? That is 4. So this is how I should be getting it. Programmatically, if you wanted to see that like how I should be doing the intersection of two sets. So let us first create a set A. So set A is having these elements. What is those elements? 1, 2, 3, 4, 5, and create a set B that are having elements 4, 5, 6, 7, 8. These are the elements. Now, if I want to do intersection of these two elements, like then I will be using a method called intersection. So A dot intersection in bracket B, or B dot intersection in bracket A. So it's like I am trying to find out A intersection B or B intersection A. And there is one more way I should be doing intersection using a bitwise AND operator. So this is the bitwise AND operator. So this is one way is actually using a method intersection. Another one way is actually this is the bitwise AND operator. So if you don't understand what is the bitwise AND operator, you can look into videos on the bitwise operator kind of video series. So there I will be discussing in detail about what is the bitwise AND operator means. So here I am using that operator to do intersection of two sets. So intersection of two sets. And one more thing is actually either I do A intersection B or B intersection A, both give the same result. So both give the same result because I am trying to see, I am trying to do this intersection. Whether this side A is there and this side B is there, or whether this side B is there or whether this side A is there. So what I am only concerned on this intersection portion, this portion. So it is so same. So that is what you should be remembering. So now, if you do programmatically bitwise operators, intersection, this is how I am trying to do it. So since 4 and 5 is common here and set A and set B, so I am getting the result 4 and 5. So either I do A intersection B or B intersection A or using bitwise AND operator. I will be getting same thing. So same thing. If you want to add one more element, assume that like if I wanted to add another element 11, here also, then result will having one more element. So that is element 11. So that is another element 11. So whatever the way you want to add into. So this is the two sets. So this is called intersection of two elements. Now intersection of two elements. And if you want to see, if you wanted to see that like, is there any common elements are there? So one is this way I have done the program finding out any common elements are there without using intersection. And if you wanted to do the same thing with using intersection, so I'm not doing calculating length of A and length of B like that earlier. So I'm just doing intersection of A and B and checking the length. If there is some elements are there in A intersection B, means like there is some common elements between A and set B. So first I'm doing A intersection B and I'm checking the length. So what is the length? Length is a standalone standard built-in function which will give the number of elements in the set actually. What is that set you are looking for? That is intersection of A and B. So the set resulted from intersection of A and B. So that I'm trying to check. If the value is greater than 0 means like there are some common elements. If it is equal to 0 means like there is no common element. So this is how, so the same, either we can do something like this, either we can do something like this. So same problem. So any problem can be solved multiple ways. It is not that like only one way is there to solve the problem. So, but which is more efficient? If you think about the efficiency wise, this is much more efficient and easy to understand. Just do A intersection B and find out the length of the that result. So it will give, if there is a greater than 0, I will be seeing that like there is a common element of there. And these are the two basic operations. What is the third operation? So we will be looking into. So we looked into union, we looked into intersection. Now next operator operation is difference. So what is the difference means? Like so we used to call no. So what is the difference between A and B or difference between set A and C? So difference between set A and set B. So what is that actually? Difference between set A and set B, or difference between set B and set A. So this is the way I should be doing. The difference between set B and set A, or difference between set A and set B. So how should we find out what is meant by difference? The difference means like, so for example, set A consists of 1, 2, 3, and 4. So this is 2. So let me rewrite again. So set A consists of 1, 2, 3, 4, and 5. So now set B consists of 4, 5, 6, 7, 8. Now if I say A difference B, then how it will work? So A difference B is actually, it will check actually which are the elements in the B, they are also present in A. So that I should be striking off. So for example, 4 is here. So I'll be striking off this 4 here. So 5 is here, I will be striking off 5 is here. And if 6 is there in B set B, but it is not there in A. So I'm not doing anything. Set 7 is there in set B, but it is not there in anything, I'm not doing. So 8 is there in set B, it is not there in A. So only which are there in set B, but also there in set A, I will be striking off those elements in set A. So what is the resultant is whatever is left out here, whatever is left out will be the resultant. That what is that actually? 1, 2, and 3. So 1, 2, and 3. This is called A difference B. Set A difference B. So it's like A. So set A difference B. That is also represented using minus operator, or I can do using A dot difference B. So something like that. A difference B. So if you wanted to see the programmatically how I am trying to do, so this is what I'm trying to do. Let us create a set A, and I'm trying to create a set B. How I'm trying to create set A and set B is the A is equal to something in the flower bracket. I'm writing those values. Now I'm trying to do difference. So what I'm trying to do, A difference B. So A difference B I'm trying to do, or I can also do A minus B. These are the two ways to find out A difference B or A minus B. So same thing, so either using difference function method or using minus function. So the result will be something like that. But another thing you should note here actually. So when I say A difference B, so when I say A difference B, this the result, and B difference A, this result may or may not be same. Either it may equal, either it may not be equal. So you should be thinking that, like, not always it will be equal. So what always so not see the not is see they may not be equal. So sometimes so it is not possible to be equal. When they will be equal, when they not be equal, actually if A and B are same, if A is equal to B, both are same, then A minus B or B minus A both will give null set actually. That is the only one time A minus B and B minus A is same. Remaining all cases, it will be not equal. So why it is not equal? Let us see it again. So same example what we are trying to do. So we did A minus B here. So let us do other way around. So take the other same example. Let us do A is here and B is here. So first put A here, sorry B here and A here. Now what is the value of B? So as for this 4, 5, 6, 7, 8. So 4, 5, 6, 7, and 8. So what is the value of A? 1, 2, 3, 4, 5. So what value of A is 1, 2, 3, 4, and 5. When I say B minus A, so means like first I will be checking elements of A. So 1. So 1, is there anything? Is 1 is there in B? No, I'm not doing anything. So 2. So is 2 is there in B? No, I'm not doing anything. So it's 3. C is there in B? No, I'm not doing anything. So 4. 4 is there in B? Yes, it is there. So I will be striking off this 4. Then 5, what is that actually? Like 5 is there in B? Yes, it is there. So I will be striking off. So what is the result? Result is not this actually. Result will be this. This will be the result. What is the result actually? 6, 7, and 8. So now if you see B minus A is giving 6, 7, 8 result, and A minus B is giving 1, 2, 3 results. So results are not same. So means like we discussed earlier, A union B is and B union A is same, or A intersection B or B intersection A is same, but A minus A difference B or B difference A is not the same. So only this doesn't become same. So, and I said actually sometimes it is same. When is that condition is it will become same? So for example, set A and set B. So now if it is a 1, 2, 3, and it also is 1, 2, 3. So what is the result? If I do A minus B, so all will be discarded. So result is null set. So whether if I do other way around, B minus A. So 1, 2, 3. So 1, 2, 3. So if I do difference, this also will result into null set. So that is the only case, then it will be same. The rest all other cases, it will be dissimilar. And if you wanted to do that programmatically, so I said, no, so this is what we do programmatically. A dot difference B or B dot difference A, or A minus B or B minus A. This is how I'm trying to calculate a difference between these two elements. And this is very, very important. So in the difference thing, A minus B or B minus A is not same. But in the intersection, either A intersection B or B intersection A result same. So even in union, A dot union B or B union A, both are same. Result will be same. In difference, it is not the case. So what is the other function? I said symmetric difference. So what is this difference between the symmetric difference and the difference? And theoretically, if you wanted to see, this is the Venn diagram. So difference, see A difference B is, this is what I'm looking into, the common element. When I'm trying to say symmetric difference, so I'm looking about this A portion and also this portion. Only thing which I'm not looking into is actually common between A and B. So when I say symmetric difference, let us discuss this again. So what I'm trying to do is actually like A and B. So the symbol to use the symmetric difference is something like this. So assume that like A has 1, 2, 3 same thing and 4 and 5, and B has 4, 5, 6, 7, and 8. Now what is the symmetric difference? Let us first do one by one. So what I'm trying to do, first I'm trying to check 4. Is 4 is there in A or not? Okay, 4 is there. So it's like I will be discarding this. I will be discarding this. So now 5 is there in B. Yes, it is there in A. It is there in A. So I will be discarding this. I will be discarding this. Now 6 is there in A. So no, it is not there. I'm not doing anything. 7 there is in A. So I'm not doing anything. So if 8 is there in A, no, it is not there. So I'm not doing anything. So similar, like once if I do something like this, so then anyhow the other way around, 1 is there in B, no. 2 is not there in B, no. 3 is not there in B, no. So then end result will be, so this one, what is that? 1, 2, 3, and this one. So 7, 6, 7, and 8. So this is called symmetric difference between A and B. So what is the symmetric difference between it's like? So whatever is here, so it's like this is whatever is left out after removing the common things between A and B will be union of those things will be called symmetric difference. It can be represented something similar like this. A minus B, OA minus B will give what is the result? 1, 2, 3 it will give, and union of B minus A. What is the B minus A will give? So B minus A will give. So what is that actually is 6, 7, 8. 6, 7, 8. So union of these two will give the symmetric difference between A and B. So symmetric difference is something like that. So when symmetric difference is removing all the common between A and B, and symmetric difference also same. Like so, whether I'm trying to take symmetric difference A comma B or B comma A. So it's like what I'm trying to say is actually, if I'm trying to do A symmetric difference B is also same as B symmetric difference A, because only thing I'm striking off is the common element and remaining all elements I'm trying to take. So either way you do this way, it's like B symmetric A or A symmetric B, result will be same. So this we can see in the programmatically. So first to do that, actually first create a set A, then you create a set B. I am trying to create a set B. Now I am trying to create a symmetric difference. What is the method to do symmetric difference? There is a function method called symmetric underscore difference. So I am using A dot symmetric underscore difference B or B dot symmetric underscore difference A. So I am using this one. Or if you wanted to use an operator, there is a cap operator, that is XOR operator usually. I will be using that XOR kind of operator. So XOR kind of operator I will be using. So A cap B or B cap A. So I will be using. And if you see the result will be same as A cap B, B cap A. So that is called symmetric difference. So what all things we look into? We look into 4 basic operations. One is a union, another is the intersection, another is a difference, another is a symmetric difference. So all these are the four common difference. And if you want to see the pictorially how it looks like, so this is how the union looks like, A union B. This is the intersection looks like. It's like I'm only interested in this red portion. In union, I'm interested in all these things. And in difference, A difference B, I'm only interested in this portion. And symmetric difference, I'm only interested in this thing. I'm not interested in the common elements. So this is how Venn diagrammatically, pictorially, I will be able to show us the what exactly means that operation means what. So symmetric difference is what elements will be considered, what elements. It's like all these red kind of thing, no, that is considered, and whatever the white thing is, that is not considered. Those elements are not considered. So union Venn diagram. So when the result will be whatever is the red portion is there, what are the elements in that red portion will be considered for that result. So I hope you understood the basic operations of set data types. So one thing we will be discussing further is actually there is something called a difference update and intersection update and something called a symmetric update. What is that means actually? So let us go back again with the what is meant by intersection. So when I do intersection, when I do A intersection B, so what is that A intersection B? So first I have to be creating A set and another I will be creating B set, and then I'm doing A intersection B or B intersection A, or I should be using what is called AND operator, A AND operator. So after doing, I will be getting the result. But am I changing any set values? No. So if you wanted to see that like the whether the set A and set B is intact or not. So it's like what I'm trying to say here is actually, so if I do A intersection B, if I do A intersection B, so then after that, like I will be getting the result. So I will be getting the result, intersection result. But this result, after that, if you see what is the value of A or value of B, this result is not modifying any of the set A or B. So it is just doing a live, and it means like it is just creating an intersection and then rendering, but it is not modifying the set A and set B. It's like what it means actually. If assume that like if A consists of 1, 2, 3, 4, and B consists of 4, 5, 6. So when I say A intersection B, so I will be getting result 4. But neither this operation is not modifying set A or set B. Nothing is, I'm not modifying anything. Even though I am applying A dot union, it's like I am applying this union or intersection anything on this set actually, but this is this set is not modified by that method. So usually that method is not modifying that set values, because whenever I'm trying to do intersection, I'm trying to use that, correct? Now A intersection means like this method I'm trying to apply in this set, this method I'm trying to apply on this set, but this method is not modifying the value of this set B or set A. So that is what see after that operation also, if you check actually what is the set A and set B value, they will be intact, they are not modified. But by chance if you wanted to modify, so the value of this set on which we are trying to do those of method or operation, then instead of using the intersection, you should be using something called an intersection and update. It's like you do intersection and also update the value of that set, whichever the set you are trying to modify. So what happens actually after this, like so after that, when you do A intersection B, now using update, so it is modifying the value of A. It is modifying the value of A, but it is not modifying the value of B. It is only modifying the value of A. And if you do the same thing, B intersection A, so it is modifying the value of B. So it is modifying the value of B. And another thing you should notice actually, so it is noticed that actually this is not returning any output. So this operation doesn't return any output. So it doesn't return any output. Means what is that means actually? If for example, if I do A intersection with update, means like I do intersection with update, so update B, so the result A intersection B is nothing. So it doesn't return value. use earlier, like if I did A intersection, A intersection B, if I do, then this will give a result. So this is another set. So this will give a result. But here, when I do intersection and update, thing, but it is not giving any output. Output is not generated. It will be null. So how can we check it actually? When I do, so like let us create a set A and set B, and I am trying to do intersection and update. So this intersection and update is not giving any result. So if this print is giving the null, seems like it is not giving any result, but this method is modifying the value of A. So how should we know? So if I print A, let me do that actually. So after this actually, instead of here, if I print here after this method, if I print here, so it is changing the value of A, because this is operating and modifying that. So null, and it is changing the value of A. So now second thing what I'm trying to do, B intersection and update. So I'm trying to do intersection and update. So now after doing intersection and update, this is modifying the value B. So it's like the value is also, but the result, this is not giving any result. So that is the reason none, but it is modifying the set B. So that is the reason the set value will be changed. So whenever we say update, so update function is not giving any return value, but it will be modifying the set on which this method is applied on. So this is modifying that value. So that value will be modified. So see, if you want to see that like whether A values are modified, B value modified, so not it only modifies the value of what is called A. It doesn't modify the value of B. So if you see here, actually value of B is not modified here. So this method is applied on A. So means like this, whatever the result will be there, no, that result will be updated on in the set. Means like it is modifying the set A, and the new values will be putting that actually. So this method is applied. So whenever you wanted to modify that set, apart from just calculating the end result, so you should be using intersection underscore update. So intersection underscore update means like update is like apart from doing intersection, it is also doing something extra work. So what is that means actually? So if this is intersection update means like actually A intersection B, I'm trying to give. So this result I will be using to modify the A. So that is the reason update is there. So similar to that, if you wanted to do union and update, so there is another one is actually difference and update, and another one is actually symmetric difference and update. So these are the two things are there. So what is that actually? So one is difference in update. What is the difference in update? So when I do A difference B, so we already know that like what is meant by A difference B. So A difference B will give the result. So what is the result? But when I say A difference and update, it's like difference and update, A difference and update. So it doesn't give the result, but whatever is the result will be there, that will be used to modify the value of A. So it's like, so that will be used to the modifying the value of A. So already we know what is the difference between A difference B. So let us create a set A. So this is set A I'm trying to create, and let us create a set B. This I'm trying to create a set B. Now I'm trying to do set A difference B. So A difference is like I'm trying to calculate A difference B. So and then I am trying to do using the minus operator. So after doing that actually, so by doing this actually, I am trying to check actually what is the changes in whether value in A or not. So I wanted to see that like any change in the value A or B. By this is normal difference function. So after doing normal difference function, it is not changing value of A. So see, A difference B or A minus B is not changing the value of A. The value of A is same as earlier. So and B difference A or B minus A is not changing the value of B. So the value of B is same as original one. But if we use something like difference and update, so now I'm trying to do A difference underscore update B. Now after that, if I'm trying to check the value of A is got modified. But a difference update, a difference underscore update is not giving any result. So this is not giving any result, but this will impact the value of a. So value of a earlier it was 1 2 3 4 5, but the value is 1 2 3. So what is that means actually? See, it is something like that. So if assume that like a and b is something like this. So 1 2 3 is the value, and here 3 4 and 5. So now what is that actually? Like now when I say a minus b, I should be getting, what is that actually? 1 and 2 I should be getting. So this is the normal method. Now if I do a difference and update b, now what I am trying to get result is none. This is none. But what is happening is actually, so 1 2 3 here and 3 4 5 here. So since this is here and this is also there, this is reducing. So now what happens actually, a is now will have only two elements, 1 2. So it is updating that thing. So it is not modifying anything to b. B will have all these three elements, but it is modifying set of a. So it is modifying the set of a and removing those common elements from the set of a. So that is the resultant will be the 1 and 2. Means like in this case, a still set a still consists of this. In this case, set a consists, after this operation, set a consists of only two elements. After this operation, so set will still consist of as the original number of elements. So same numbers of elements will be there. But if you do difference underscore update, then original elements like set a will be modified. So and the resultant value. And if you see actually this operation doesn't result in any result. So, but the normal difference operation will give the result. So this is the difference between just difference func method or a difference underscore update method. So difference underscore update method will modify on the set on which it is applied. The same thing we discussed intersection update, and same thing is symmetric difference and update. So what is the difference actually? Symmetric difference is calculated with symmetric difference, and then when we try to see that like update, so it is trying to do. When I'm trying to do symmetric difference and update, let me check actually. Symmetric difference and update is trying to change. So what is the trying to change actually? It is trying to change the value of on which it is trying to apply. So on which it is trying to apply. Let me see here actually. In the first case, I am trying to apply symmetric difference. So on A, but this is normal symmetric difference A, and I am getting the result, but it is not modifying neither A neither B. So it is not modifying, because if you see the symmetric difference, A symmetric difference, this is the value. But if you see the result of A is same, the set of A is same as the original. This is set of A. So the set of A is same, and set of B value is also same. So I am not modifying. So this symmetric, normal symmetric differences give the result, but it doesn't modify any of set. So the same way, the symmetric difference is operating on set B, neither modify B, neither modify A. So after that, so A and B will be as same. So result will be the same. So A is same here. So like original, B also same as original. But if you wanted to use a symmetric difference A, so if you want to do symmetric difference A, this method after applying that, like the result will be none, but it is modifying. So if you see here actually, what is the initially A? This is the initially A set. So this is 1, 2, 3, 4, 5 is the initial set. But after that, like 1, 2, 3, 4, 6, 7, 8. In fact, it is modifying the set A on which this method is applied. Symmetric underscore difference underscore applied. Update is applied on the set A. So the set A is modified, but set B is not modified. If you see actually set B, originally 4, 5, 6, 7, 8. So here also originally 4, 5, 6, 7, 8. So it's like symmetric underscore difference underscore update is modifying the set on which this method is applied. So if there is no update, underscore update is there, it does that operation, but it doesn't modify the result. So that is the difference between these functions. Like, so what we look into? We look into union, we look into intersection, we look into difference, we look into symmetric difference, we look into difference underscore update, intersection underscore update, symmetric difference underscore update. So this update is actually on which method we are trying to apply that values will be modified. So if you wanted to modify that after the set values, then you should be using update method. And if you don't want to modify those sets, just you wanted a result, then you should be using normal with not having an underscore update. Normal functions like union, intersection, and difference. So those normal functions you should be using. So with this, I will be concluding about this video. This video only discusses about the 4 basic methods of union, intersection, difference, and symmetry difference, and also modified version of those methods like difference underscore update, intersection underscore update, or symmetric difference underscore update actually. And these are the methods we will be discussing here. So apart from that, like there are few more methods are there, like use disjoint, use subset, use superset, and some built-in functions are there. We will be discussing in the another video because so this set data type is bigger one. So we'll be discussing part by part some of the things. Like so in first video we discussed about the basic operations, and now we discussed about the some set operations, basic set operations, and next we will be discussing further set operations and some common methods actually. We will be discussing in the further videos. Thank you.